Today I'm doing the Diet Coke and Mentos experiment. I'll be testing whether or not the height and the shape of the bottle will change the eruption. Warning, task performed by non-professionals. Stay safe. This is going to be my control. It's going to be the first one I do, and it's going to be the one that I test the others by. This is my independent variable. This will be poured to this and this with this to use the same amount of soda in each one. The test that I'm doing is, will the height of the bottle and the shape of the bottle affect the height of the eruption? So these are all different shapes. So when I pour the same amount of soda in each one, judging with my measurements by this, I put the same amount of soda in there, they should cause different eruptions. So these are my variables, my independent variables, and this is my control. And then these two are my constants, the thing that will stay the same through all of my tests. Now it's time for the test. Okay. The test. My dependent variable. It is going to measure the height of each eruption. Time for the control. I'm going to take 3 Mentos, drop them at the same time, and then move away from the bottle as quickly as I can.
Right at 7 feet.
That was my control. Now, I will measure this bottle into the 3 of these bottles with the same amount of soda. This is a 2-liter bottle of Diet Coke. This is judging by milliliters. 1,000 milliliters equals 1 liter of Coke. So I'm going to go up to the 2,000 milliliter mark, which if you divide 2,000 by 3, you'll be using just under 700
milliliters.
I've gone just under 700 milliliters. I'm going to pour it to my other dependent variable bottle. This is going to be the constant. That is just under 700.
Take the cap off, take it over there, let's go.
Now I will test. It did nothing. Apparently that was too little of Coke for the eruption to come out of the bottle.
Is this recording?
It wasn't a very good experiment.
Transfers of the heat and the gases that transfer when you poured it into the other plastic are causing it to not act right.
I did some research. When the Coke was transferred into the thing, the air changed the gas molecule. So when I poured it back into this bottle, it did not work the same way. The next one I will do is 700, but it has not been transferred into the open air. And I just ate a Mento. Now, since the other ones weren't working well, in Miss Buster's fashion, they always try to make it go higher, the other ones. So I will shake up this bottle of Diet Coke, and I'll put as many Mentos as I can in there before it starts to go off.
Oops.
After we pick them up all off the yard. Take it good.
It's coming.
That one was tough to measure.
Since our last experiment did not work because of the transfer of the gases to the air when we were transferring the soda to different bottles, we went out and we got bottles that already had the soda in them, but they're different sizes still, but different amounts of soda. This is a 1 liter bottle of soda. This is a 600 milliliter of soda. We will start with the liter.
Two and a half feet.
Next will be the 600 milliliter bottle. I will put the same amount of Mentos, 3, into the bottle. Now in true Mythbusters fashion, I'm going to try to get the most amount of Mentos and a shaken up bottle into the thing at the same time.
Go! Go!
I told you it was not
Keep
gonna work.
going!
Yeah, that didn't work. This experiment was confirmed. The experiment did go 7 feet, but the other ones, the half the size, did not go half the height. Due to the air, when I transferred the gases into the other bottles, it did not work because the gases were released into the air that I needed to make the explosion for the Mentos. Once again, it was busted.